Hello everyone. This is my case study in classification of AI versus human written essays as the final project for the CSCI S89 Introduction to Deep Learning Harvard Extension and Summer School 2024 course. Now, the problem summary is that in the rapidly evolving field of generative AI, distinguishing AI-generated text from human-written text remains a critical challenge, and there can be implications in how essays are marked in academia, online content moderation, and user-generated digital content creation. Now, this project proposes to use the supervised deep learning methods we learned in class to build a classifier which attempts to classify AI or human-produced texts. The dataset I have chosen is a popular dataset on Kaggle. It is called the DIGV2 dataset and has over 40,000 essays in total, with over 25,000 being human-written from 6th to 12th grade pre-college students, and 15,000 or more AI-written essays. And we can see that in the bottom right corner of this page, that in addition to the generated essays, they are labeled. So a label of 1 means that they are AI written, and all of these essays were generated or written based on certain prompts, such as car-free cities or distance learning. And there's also a source column where it came from, or what large language model AI was used to generate these essays. And finally, there's a Riddle 7 column, which was used for a Kaggle challenge we can ignore in this project. Now, specifically, I used an LSTM, a simple recurrent neural network, and a bidirectional LSTM with very similar structures, and these were trained for the classification task with dropout layers to prevent overfitting. The models achieved on average 97 to 99% accuracy on the validation data, which is 20% of all the data, compared to a simple benchmark logistic regression that only achieved a 64% accuracy, right? I also created a simple application as shown here, a text box that can be used to input text. It shows first that a prediction of whether it was human written or AI written, and a confidence level along with that prediction. And a preliminary conclusion after a series of tests was that this classifier, specifically the bidirectional LSTM, which was used in this simple text box widget, adheres to this scaling law of increased data resulting in potentially more accuracy and robustness. Specifically, it might help in decreasing false negative rates. So AI-written essays that were incorrectly identified as human-written, these rates can drop. And finally, since scaling law holds and we are classifying AI essays, synthetic data may be used for any further experimentation with this task. Okay, more detailed introduction to the data set. Now, the data set, there's over 15 different large language models used, as you can see here. Llama 2, Mistral, ChatGPT, Falcon, Cohere from Canada. And the Persuade corpus was the corpus of human essays, and these were limited to essays with a minimum of 150 words. 75% had to be correctly spelled English words, and these were all written by students from grades 6 to 12 pre-college. Now, more specific exploration of the data. There were 15 different prompts used in essay topics, so the data was fairly standardized, with some having more human-written essays and some more AI-written essays. So we can, for example, see car-free cities, which had a series of human-written AI-generated essays on this specific topic. Now, the data was pre-tokenized using a TensorFlow tokenizer, and also split into 80-20 training and validation data. The model designs were actually fairly simple after a series of trial and error. So we first have an input layer, which is the embedding layer with max features of 10,000. 128 output dimensions, so we are trying to have some sort of dimensionality limit or reduction and a max length of 150. So we just keep two layers of it'll either be an RNN and LSTM or a bidirectional LSTM. So that's an LSTM wrapped with a bidirectional wrapper, and it'll have 64 neuron units in each layer, followed by dropout layers in between, so with a 50% dropout rate that is randomly set to 0, obviously to prevent overfitting in our classification exercise. And finally, an output dense layer with a single unit, and also with an activation, sigmoid activation function for obvious reasons. Since we are doing a classification task, we want a 0 to 1 single output. And that's the model design. In terms of the training process, the training was also fairly simple. As I compare the LSTM and RNN here, I didn't actually graph the bidirectional LSTM training on the same graphs, but the results were quite similar. So both were just trained for 5 epochs with a batch size of 32. The LSTM training time is somewhat longer, slightly more than 2x per epoch compared to the RNN, so it would be something like 30 something versus 80 something seconds, which is roughly expected given that how we understand the architectures. The LSTM is somewhat more complicated. So the LSTM start off as a very high accuracy rate, while the RNN does have to climb in around 3 to 4 epochs, and the validation loss drops quickly, while for the LSTM we can see that the validation loss is actually quite flatlining very quickly, and both achieve accuracy rates of over 98% within 5 epochs. And there might be overfitting, and truly out-of-sample text may not work that well when I first look at these training performances. It does seem too good to be true, but more results will be shown later on with specific tests. Also, I created confusion matrices. There's not too much to see here. So the confusion matrix, 1 is for AI and 0 is for human. And we do see along the the left diagonal most of the validation data set, so around 8,600 something essays, and very few false positives or false negatives were seen in both the LSTM and the RNN models, with more false negatives than false positives is a trend. And here we actually see, again, confusion matrices. I compared the final bidirectional LSTM, which would be the most robust, with a 99% accuracy rate, compared to the logistic regression, which is just a very simple logistic regression, and that only had a 64% accuracy. I was tweaking it actually later. If I choose to do some vectorization, I can actually get the logistic regression up to a 99% accuracy. It just doesn't work well with tokenization, which is more fitting for these recurrent or long short-term memory models. And a more specific breakdown I generated by the prompt names. As we can see, the error rates are all below 0.1, so the error rates were very low. There were no significant outliers, and there are still differences in different error rates by prompt. So something like distance learning using an RNN would have close to a 6-7% error rate, but these are too small, I think, to be significant, and no further exploration was done here. So I also tested individual essays with a simple widget I made. So for example, these are baseline benchmarks. So a random essay copied from the dataset used that was AI generated had 99% confidence, and a random human written one also had 99.97% human written prediction confidence. And everything was done using a bidirectional LSTM. So these should be correct. So I tested new essays in-sample AI prompt, first of all. So I just used ChatGPT. I used the ChatGPT 4.0 version by OpenAI, and I asked it to generate a 200-word essay on mandatory extracurricular activities, which is one of the prompts in the original dataset, and pasted that into my widget, and it came up with the correct prediction with a 99.95% confidence. Here's an interesting one. So I took a random sample, out of sample AI prompt. So I thought of something like generate a 200-word essay on fiber optics and cloud computing, which is not remotely related to any of the prompt topics in the original data set, and is probably a topic that's much more advanced compared to topics for grade 6 to 12 students. And so the classifier actually incorrectly classified this as human written, but only with a 74% confidence. And so I thought this might be due to not having seen any of the vocabulary in the very large training data set. And so without it being seen, it has a larger likelihood, having been unique, that it's human written. So given the results above, I also tried a mix of in-sample prompts, so phones and distance learning. There were 2 prompts on, one was phone usage and the other was distance learning, and I combined them. So this is a mix of in-sample prompts, and this was correctly classified again as AI written with 99% accuracy. And finally, I tried to mix in and out of sample prompts. So what that means is distance learning, which was one of the prompt topics in the original training data set. I combined that using fiber optics, which was the one that I came up with that actually became incorrectly classified. I combined those two and asked ChatGPT to generate an essay, and this one was also correctly classified as AI written with 99% accuracy. So it does seem like, this is one example, but I tried a bunch of examples, and it does seem like that anything that was within the training corpus, that this classifier will be able to classify correctly, even if I add out of corpus information. And here's a bonus test with robustness to shorter texts. Obviously, the classifier is not very robust to very short text, and it's almost actually impossible to tell whether something like "my name is Jason" is AI or human written. It could go either way, right? So I actually tried to put in a obvious spelling mistake, purpose spelled as poise in this case, and it still predicted incorrectly, being AI written on the top half. However, if I add some characteristics that's obviously human made, let's just say I just copied and pasted "don't think, good idea" repeatedly. So AI large language models do not generate repeating text. And that's obviously human written, and the classifier then correctly identifies it as human written. That's something interesting, right? So final summary of my observations and conclusion. The simple application was created. I used the LSTM, simple RNN, and bidirectional LSTM models for the classification task, training on 30,000 plus essays and validating them on 8,600 or so essays, achieving an accuracy of 97 to 99% accuracy with all 3 models, compared to a simple logistic regression with only a 64% accuracy for benchmark, right? I also created a simple application, a text box that classifies the essay as AI or human, and also gives the confidence percentage to go along with that. Now, some observations and insights, that there are some obvious limitations, as we saw with AI-generated essays. They're highly, there's definitely patterns in them. They're highly similar. There's incorrect mathematical calculations, for example, that are predominantly seen in LLMs, and that could classify these as AI-generated, or a longer text could be a trait of human written essay, or repeating words or spelling mistakes could be traits for human written essays, right? And finally, a preliminary observation I found was that based on the example that was the out of sample which was incorrectly classified, but with only a 74% confidence level, I thought we could infer that the scaling law would hold with our deep neural network, specifically the bidirectional LSTM. So more increased data would result in increased accuracy and robustness, and this would likely decrease the false negative rates, which we saw there were more false negatives than false positives, which is AI written essays being incorrectly classified as human written. Because the more you show it AI written essay topics, the more it correctly identifies these. And so by induction, once it has seen every topic in the English language, we could probably get false negative rates to near zero, right? And our observations did support this. And finally, because the scaling law holds, the synthetic data may be useful for scaling the model. You can actually use AI-generated essay model to train these the LSTM or RNNs for further exploration. And that is my presentation. Thank you for having me in this course.